And we're live. Nothing. I love that we can present to everyone. That way no one can see us.
Yeah, nobody can see him.
Yep, that's a nice little feature. They can just stare at my screen and hear our voices.
They don't have to see me.
Okay, so I guess should we just go over the prep assignment?
Sure.
Okay. So part 1. Use the information on the baseball batting averages given in the reading assignment to complete these questions. This information is found in Lesson 5, Section 2.2.2, Baseball Averages, the online textbook. Classify each of the following batting averages as either unusual or not unusual. Use the z-score to make this determination.
I like how they can't put just like usual for
Yeah.
not unusual.
Yeah. I know, I saw that too. It's like, what? Okay, so you just plug it in and you get negative 2.088, which is unusual. And B, 0.225, z-score, minus 1.059, not unusual. And yeah,
Do you remember why they're usual or unusual?
there's a range that they have to fit in.
Between -2 and 2.
Yeah,
So if it's anything smaller or bigger than -2 or bigger than 2, then it'll be unusual. Which that's kind of nice. You can just tell right away.
yeah. Okay. Perfect. Number 2.
Find the probability that a randomly selected professional baseball player will have a batting average that is greater than 0.335. Use the z-score and the normal probability applet to find the probability. Did you guys play around with that?
Yeah,
Mhm.
I played around
Yeah.
on it.
It works.
I need to open that up though. Oh.
Well, I've got it open up too. Well,
Oh.
when we need it.
Yeah, I guess I don't really need to open it then. Okay.
So
So I mean,
Yeah,
you
you
just
just
plug
copy
in
the
2
point.
point, yeah, and it shows you. You just got to be careful about what side you highlight.
what side you're looking for.
Yep.
Because even though it shows, both the positive and the negative, what you calculated your z-score to be is what you should be looking at.
Mm-hmm.
So if your z-score came out negative, you always want to be looking at that point of it,
Yeah.
or comparing the whole thing to that point.
Yeah. Exactly. Okay.
Provide a brief description of a normal density curve. Describe the shape and the properties. That's just a normal bell curve.
Yep.
Comes from the standard deviation.
Okay. In the following z-score formula, z equals x minus mu divided by, I forget what that symbol is called.
I don't know what it's for though.
Theta.
I don't know that symbol.
Yeah. Please state what each symbol stands for. Okay. So Z tells us standard deviations away from the mean. X is the observed data point. And mu is the mean of the population. And whatever you call that symbol is the standard deviation. Right. Okay. In no less than 3 sentences, please define and describe the 68, 95, 99.7% rule. So 68 is just 1 standard deviation, 95, 2, and then 3 for the 99.7. Yep.
Very simple.
Nice.
Okay.
You'll fill smart out during.
All right. So
We have to find the mean.
Right. Yeah, it's already
Yeah,
good.
it's already up there, 150.
yeah, standard deviation is given too.
8.8.
So we're good. And then what proportion of the people who take the quantitative portion of the GRE will score above 165? So we take 165 and we'll divide it by the mean.
We'll subtract it.
Oh yeah, subtract it from the mean.
Divide by
And then
8.8.
Divided by the standard deviation. Okay,
1.6136.
right.
What is the quantitative GRE score for a student who scores in the 10th percentile?
Oh, so you just plug in 10% to the area on that little thing,
Yep.
and then it gives you the z-score. Okay, so it's negative 1.2816. Okay, so what is the quantitative GRE score for a student who scores in the
10%.
percentile? Oh, yeah.
So that's when you have to rewrite the equation to solve for x.
Yeah. Yep. So,
Room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of 1,800 meters per second and a standard deviation of 600 meters per second.
So what is the probability the randomly selected particle has a speed over 2,500 meters per second? So you go back to solving to the z, which would put 2,500 minus 1,800 divided by 600. It gives you 1.1667. Put that in here. Z on your little applet. And then highlight everything green.
looks good. 0.1217. Okay, what is the probability that a randomly selected particle has a speed that is less than 2,500 m per second? So just, same thing. Just take 2,500, subtract it by 1,800, divide it by 600. And then you plug in 1.1667 and you get both areas shaded, the middle and the other side, to get an area of 0.8783.
Or you could have left all of your data in the first graph you did, and then you just select the two bottom halves and unselect your top half.
Oh yeah, that'd be easy. A lot easier.
Yeah, click some things.
Okay. So we're on D, right?
Yes.
So what is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? Okay.
So it's kind of like the other two, except instead of using the 2,500, we have a new x value of 1,500.
Yeah.
So it'd be 1,500 minus 1,800 divided by 600. That's negative 0.5. And you just do the same thing, plug it back in and shade everything under your z point.
Yep.
And that's where you gotta remember what the sign was for your z point. Because if you went and clicked on the positive side and selected everything under it, you get a bigger area than what you're actually looking for.
Mm-hmm. So just gotta watch the signs.
So what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? So we go back and subtract the probability of our first point, the 2,500, and the 1,500. We subtract their z points from each other. But we do it so that our answer is positive, so we'll take the smallest from the biggest.
Mm-hmm. Yeah. Yep.
What is the third quartiles of the speeds of hydrogen at room temperature? The third quartile is 75th percentile. Anything larger than 75% of the speed.
So then you just plug in 0.75 for the area to get the z-score, and just plug in the values. So then you get 2,204.4 once you plug everything in. Okay. During your group preparation meeting, you will determine whether the data represented in these QQ plots are normally distributed or not. Record your answer for each graph. Justify your answer. Gotta make sure that Trevor didn't call. Oh, text message. Oh, I think he did. Hey Jordan, I'm really sorry, but I forgot about my choir performance tonight on campus. I won't be able to make it to the math group meeting. I'll be there on Tuesday though.
Okay.
Okay. So this first one, it doesn't look normally distributed because it's like, boom.
Right skewed.
Yeah, right skewed for sure. And then this one looks pretty normally distributed, doesn't it?
Except for the S curving.
Oh, yeah, okay. So that's not quite normal. This one, I don't know what you guys think.
What do I think? Or
Yeah, what do you
say?
Is
If
it,
I were to look at it and tell you what I think, I would think that it's not normal because of the curving. That S shape. Because the normal looks like plot F,
Yeah.
kind of linear in plot D.
but it says it's
But it says that
normal
it's
just
normal.
because it.
Just because it represents normal data.
Oh, okay.
But overall, it follows a straight line.
Okay. So I'm guessing this is normal too, right? Plot D. Okay. And then snakish, but it looks normal. And normal.
But it's not normal
Oh, this is not normal.
because of that.
Plot E is not.
Okay. Not normal. Downward curve suggests the data are skewed right.
Now we have to do some practice problems.
Okay.
I think that's what the assignment was. What's the quiz?
Huh. All right. So now we're doing the quiz.
Sure.
Okay. Okay. Total area under a density curve must equal 1.
Yeah.
Under certain circumstances, the density curve can drop below the x-axis. False. A normal density curve is symmetric. True.
It's one of the definitions
That's one
for
of the
normal
definitions. Yeah,
Mel curve.
it's true.
Okay. Use the following image to answer questions 6 and 7. Which of the following elements of the figure represent the z-score in this image? This one.
C.
See. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1?
So I think it'd be B.
Yeah.
Because if our Z is 1, a positive 1, then everything to the left is less than, and everything to the right is greater than. But that's where I wasn't really sure.
I don't really know what it's asking exactly. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1? Well, yeah, B, because this right here is what this is. So for it to be greater than that, that would, yeah. Okay. Okay, according to the 68, 95, 99.7% rule, what proportion of the data from, oh shoot, yeah,
68.
It'd be within 1.
68. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal. Alright.
We're at 9, right?
Yeah, it's between -1 and 1.
So this is what I did. I put -1 and 1 in the Z-score, and then just selected the area that's between the two. And gave that area as the answer.
Yeah.
Which I got was 0.683.
6, 8, 3. Okay. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
Three decimal places.
Same thing.
Yeah.
And we got 0.955.
995, you said?
955.
So 955, sorry. Okay. Suppose random variable z has a standard normal distribution.
That's 0.997.
Okay. Look carefully at your answers to the last 3 questions. What you observe.
16. It's my
They all match the
That was my
rule.
Yeah.
Okay. The amount of protein that an individual must consume. Wait, let's read this part first. What proportion of the population have a protein requirement that is less than 0.6 g?
So you give me my notebook.
Yeah.
So this is the one where you have to start using the equation. And so all you do is plug in your data points and get your z. So it wants to know about 0.6 grams, right?
Yep.
And the mean is 0.66 and the standard deviation is 0.07. And so that's your x, your mu, and your
Standard
whatever it is.
deviation.
Yeah. So you just plug all
Plug
that into your
everything in.
calculator. You get
This-
-0.857 z.
Yeah, for the z-score, and then you
And
just
then
plug
you
that
just-
into the applet.
Yeah.
Okay. What?
Yeah. So I ended up getting 0.196.
196. Okay. Cool.
And then 14.
I'll take it when you guys are done.
14 was it was that same bell curve. I just had to select everything to the right
Oh, okay.
to get the greater. And it was an area of 0.804.
Okay. What proportion of the population have a protein requirement that is less than 0.7? So same thing, you just have to plug in 0.7.
Yeah, so it's the same equation. You just plug in 0.7 and you get z equals 0.571. Plug that into the bell curve and select all the area that's less than 0.7 and it's 0.716.
Okay. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Hint, remember that to find the area between 2 values shade to the left of each z-score. You calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the 2 values. Give your answer as a decimal, accurate to 3 decimal places.
So then on our areas for question 15 for the 0.7 grams, it was 0.7160 for everything to the left. And for 0.6 grams, it was 0.1957 for everything to the left
Oh, okay.
because it was a negative z.
Okay.
And then you just subtract 1957 from 7160. And I got 0.520.
0.520?
Yeah.
Okay.
Find the 35th percentile.
So find the 35 percentile for the protein requirement for adults.
Define the percentiles. you do. No, my trackpad's getting all goofy. There we go. So that's when you just
Plug it in for the
plug it in
B.
for the area.
Read that.
And that's your Z value.
Yeah. Is it 454? Is there one more step that we have to do or something?
Oh, okay. There we go. So for the area 0.350, it's going to be down in this quadrant. And it gives you a Z score of 0.38.
Zero 0.38.
0.385.
385.
Okay. So then just the same thing with 0.8 for P.
And then for the
Find 80 percentile.
that gave a Z score of 0.842. See, and for the 35th, did you put a negative in front of
Mm-mm. Is it negative?
that? Yeah.
That's it.
Okay.
Wait, what?
Do you think we missed anything?
So here's the other part that maybe I didn't understand. For 17 and 18,
Uh-huh.
I solved for X in the formula, but
Okay.
I'm not sure if you have to.
I would think that you do need to solve for X, wouldn't you? Because it's not just asking for the Z score, it's asking, right?
So calculating percentiles using a normal distribution, right?
Yeah.
Percentile, for example, blah, blah, blah. So first we need to find the Z score that corresponds to the 90th percentile. So we found the Z score. Yeah, so we do have to solve for X.
Okay.
So then we plug that back into the equation. Rearrange for X, solve for X. And I got 0.633.
Okay. 0.633.
Take the negative off.
And then 0.719.
Okay, so that's just rearranging the equation.
Yeah.
because we have the z-score now, so we can plug that in on the other side, and the x is the only thing we don't know, which is what we're solving for.
Yeah, so then we have to rearrange our equation to solve for x. And
So you multiply it by 0.07,
and
then you added 0.66. Okay.
throw it in the calculator and spits that out.
Sounds good.
So
Show me to submit it first. I'll submit it first. You can wait.
Okay, leave it there. If I get this, still take it in.
I'm nervous.
You scared about this? Oh, it's not, it doesn't want to submit. 90. That's not bad.
100 minutes.
Yeah, what'd you miss?
I just plug it in wrong for 9.
For 9?
0.683.
You think you put negative?
Yeah, you did.
You put negative, that's why?
Yeah.
I'll take it now. Is that all you missed? Oh, and
17 we got wrong.
17 you got wrong.
17.
What'd you put for 17, Eric?
I had 0.633.
That's wrong.
No, I think I put an extra dot. If
I think you do have 2 dots there, yeah. Now I'll take the quiz. No. I'll just copy his answers because we already took it as a group.
Yeah.
I'll just have him give me his answers.
Okay, well, let's
We're done.
stop our broadcast.
Bye bye, people. We'll see y'all later.